Hi, in this video I'm going to talk about implementing local data access in .NET MAUI using SQLite databases and the Model-View-ViewModel pattern in a cross-platform approach using Visual Studio 2022 as the development environment. So in Visual Studio 2022, the first thing to do is creating a new .NET MAUI app. We can choose a name of our choice, so for example, local data access. And we select .NET 7. We wait a few seconds for the project to be ready. Okay, now the first trick from the real world. Sometimes and completely randomly, you might experience an error when you install the NuGet packages for SQLite from the NuGet package manager. So we need to manually install the NuGet packages. More specifically, the libraries that we need are the following: SQLite PCL NET version 1.8.116 and SQLite PCL row.bundle_green. And the minimum version is 2.0.4 or higher, of course. So let's go install manually both libraries. And to do so, we go into Tools, NuGet Package Manager. We open the console. And the first line that we are going to type is the following: install package SQLite NET PCL version and the version number, which is 1.8.116. We press enter. The NuGet package is installed, and this action also installed the other dependencies, but we need to manually do this other step. So we need to install also the other library, which is the SQLite PCL row.bundle_green. This ensures that we have the latest version of the library. You would not do this in a normal way, let's say, but sometimes you might get an error. So this is the way to avoid the error. Now, as I mentioned in the introduction, we want to add a simplified customer representation to manage a simplified customer list. So let's go adding a new class. The class is going to be called customer.cs. This is something that is quite annoying. So every time you add some code files, the project file is also opened, but we really don't need this. So let's go into the new customer class. I will use some boilerplate code that I have somewhere else. So I have this class, and as you can see, Visual Studio automatically adds the necessary using directives. So we have a class called customer. This attribute, the table attribute, allows us to specify the mapping to a database table. In this case, the table is going to be customers. So we have the ID field for this row. Everything here is done by implementing the property change the pattern, and the reason is that we are using the Model-View-ViewModel approach. So every time the data in the customer instance changes, we also want to automatically update the user interface. So this is quite simple. We use these attributes here. This is the primary key, and this auto increment, so we don't need to manually handle the identifier. Then we have the company name, again a backing field of type string, and then the property. This is marked with the not null attribute, so we want this to always have a value. the physical address, backing field, and property. This has a max length attribute. The country, backing field, and property, and the property changed interface implementation. Okay. And one thing that is missing here is the iNotify property changed interface implementation. Okay, so now we have the model, and the next step is implementing a view model with the business logic. The view model is going to be called something like customer view model. Now I'm going to add some business logic here. You will see invocations to method that point to the SQLite database implementation, and that we are going to do very shortly. Again, I'm posting some code that I have somewhere. The view model is still implementing the iNotify property change interface. So here we have an observable collection of customer, which is data bound to the user interface, and that will represent a list of customers. So when an object in the collection changes, also the UI is notified. We have this property called the selected customer with its backing field of type customer. This represents an individual instance of the customer class in the user interface. The database connection class is something that we are going to implement very shortly, and that represents an instance of the class that points to the SQLite database. So here in the constructor we have a method that retrieves the list of customers from the database. It creates a collection, an observable collection of customer instance class. If there is no customers in the list, a new one is added with this method called addCustomerAsync. So we create an instance of the customer class, the customer instance is added to the collection, and it is saved into the local database. Because we are working with the Model-View-ViewModel pattern, we will not handle button clicks in the user interface, but we have commands. So we have this command called save all. All the objects in the customer's collection will be persisted to the database. Then we have this other command, add new, which will add an individual customer instance to the database. We have a delete button, a delete command, sorry, which is going to delete an individual row from the database. And let me tell you one thing. This is for demonstrational purposes, but remember that in the real world development, you will likely mark an object as not available, rather than physically deleting a customer instance, a row instance from the database. And the property changed implementation. Now the very interesting part, so the data access class. We add a new class called database connection. And I am also adding some code here that I'm going to comment very shortly. So we specify the name for the database, customers.db3. db3 is the extension, is the file extension for SQLite databases. We have a few flags from the SQLite open flags enumeration. We want to make sure that the application will be able to read and write a database file, create a database, and enable multi-threaded access via the shared cache value of the SQLite open flags enumeration. We have then this read-only property, which returns the full path name for the database file in a cross-platform approach. So this way works regardless of the operating system the application is running on. This is one of the very cool things in .NET MAUI. This field database of type SQLite async connection represents, we can say that it represents the instance of the database. So it is the class that makes it possible to access the database on disk. We also want to use an approach called lazy initialization. So we create a method called init that creates a new SQLite async connection object with the specified database path and the specified flex that we declared previously. If there is no instance of the database, we return. If no table is found on the database, we create one. If a table already exists, this line is simply ignored. And then we have methods that retrieve the list of objects of our interest. So for example, we want to retrieve the list of customers from the database. So we invoke the table method. This is a generic method that wants the type of object as the type parameter that we want to retrieve, and we convert the result to a list. We can also retrieve an individual customer from the table, specifying the appropriate ID. We use the first or default async method, but basically we are executing the same query invoking the table method. This method demonstrates how it is possible to filter the list of objects that we want to retrieve. So here we are executing a link query, filtering the list by country name. This is very interesting because we are saving an individual customer instance. When you create a new object in memory, the ID is going to be 0. This is filled in when the database when the new customer instance is added to the database. So if ID is 0, it means that there is a new item that must be inserted and saved. Otherwise, it must be updated. So the SQLite async connection class exposes method for working with the so-called create, read, update, and delete operations. So we have update async, insert async. This other method is also here for demonstrational purposes and allows for saving all the instances of customer objects in the collection. So we have a for each loop, and we understand if there is an ID or not for each customer instance. And in the end, the delete method. But as I was mentioning previously, you likely want to mark an object as unavailable rather than make a physical deletion. Notice that every method is calling the init method, so to put in place the lazy loading approach. Okay, now that we have our database data access class, we can go to work on the user interface. The user interface is also quite simple, but it serves for our purposes. So let's go to the mainpage.xaml file. We are going to completely replace the content of the auto-generated user interface with the following. So I have a root grid layout where I have inside a collection view object that allows me to display a list of bound customer instance at this point. So we are going to display the list of customers observable collection assigned to the item source property, and we are also binding the individual customer instance to the selected item property of the list view. We have a simple data template. The identifier, the ID, is displayed inside a read-only view, the label. All the other properties of the customer class are displayed via entry views, so it is possible to edit the fields, and every view binds the text property to properties in the customer class. At the bottom, we have a stack layout with 3 buttons. Each button is data bound to an appropriate command. So add new, delete, and save all. This is all for demonstrational purposes. In the code behind file, so the CS file for the page, we can first of all remove the auto-generated code. Then we should declare a property of type customer view model in this way. It is appropriate to use a property here because properties better support data binding. And the very last step is assigning the view model property with an instance of the customer view model class and assigning this view model instance to the binding context property of the main window, of the main page class. In this way, we are connecting the data source with the user interface, and they will talk to each other automatically thanks to the Model-View-ViewModel approach. Now, let's go to test the results, and we are going to do this with an Android emulator. So, let's start. I am using an Android emulator here because the reason is simply that I'm used to work with mobile devices, Android and iOS, but this is a cross-platform project, so it will work on any of the supported platforms. The emulator is loading. It might take some time if this is the first startup of your day. The application is starting. This is quite normal because there is we are running the app in debugging mode, so it takes a few seconds more. Okay, so if you remember the logic previously, we said in the code that if there is no customer in the database, we add a new one. So this is the new customer added by our source code. As you can see, there is an ID because the new customer instance has been automatically added to the database. So let's write something here. LTD somewhere street, country can be whatever, my country, okay, and let's save. We can add a new one, another company, another street, and another country. Okay, now for example, if I restart the application, I will see both customer instances coming from the database. I can select an instance, I can click remove, I can save. If I restart the application, I will see that the instance has been properly removed from the database, keeping in mind my suggestion about record deletion. Obviously, there is plenty of improvement to the code. For example, you might implement something that automatically reloads the data instead of restarting the app, but this is more for demonstrational purposes to really demonstrate the data and how the data is being handled in the database. So I think it's very nice the way you can work cross-platform from a single shared code base in .NET MAUI against SQLite databases, and using the Model-View-ViewModel approach. So, very last thing, I will leave you the address to download the source code for this video, which is on my Patreon space. And if you liked this video, please like it on YouTube and subscribe to my channel. Thank you very much for taking the time to watch this video.